Hi. Now what we have here is a nice example where we are given this cubic expression and asked to use the factor theorem to show that x plus 2 is a factor of f of x, and then go on to factorize f of x completely. So if you haven't done this already and want to give it a go, just pause the video for a moment, come back when ready. Or if you're unsure about the factor theorem, you can always go on my website ExamSolutions.net and look at the tutorials on this. Okay, welcome back if you did have a go. So let's just see how we'd go about part A. So we're given this cubic expression, f of x equals 2x cubed minus 7x squared minus 10x plus 24. And if we're to show that x plus 2 is a factor, you should be familiar with the factor theorem. Just briefly, it is that if f of x is a polynomial, and we've got a polynomial here, and f of a equals 0, that's when we substitute any value for x into here and it comes out to 0. Then if f of a equals 0, then x minus a is a factor of f of x, and this is called the factor theorem. So what it means then is that if we're to show that x plus 2 is a factor of f of x, then we must work out what f of minus 2 is. We would hope that f of minus 2 would give us 0. And that would mean that if a is minus 2, x minus minus 2, in other words x plus 2, will be a factor of f of x. Okay, so let's just do that. Let's put part A down. We'd go for f of minus 2. And what's that going to give us? Well, if I show that I'm substituting it into here rather than just saying it equals 0, I'm just going to put 2 times minus 2 all cubed minus 7 times minus 2 all squared, then minus 10 times minus 2, and then we've got the plus 24. I would suggest you do that just to show people that you've actually put minus 2 in place of x. And if we work each of these individual terms out, you'll find this term comes to minus 8 here times 2, which is minus 16. Then you've got minus 2 all squared, which is 4, times the minus 7 is minus 28. And then you've got minus 10 times minus 2, which is plus 20. And you've got plus 24 on the end. Add these up, and indeed you get 0. So therefore, we can say that x plus 2 is a factor, okay, of f of x. So I feel that you got to just wind that question up by saying that. Okay, well, there we go. That's the first part then, part A. And now for part B, we've got to factorize f of x completely. And there's two ways that we can do this, and I'll go through both ways. First of all though, what we've got is that f of x, we've seen now, is going to be identical to x plus 2, okay, multiplied by another factor. We've already seen that x plus 2 is a factor of f of x. So in order to get a cubic equation, this other factor must be what we call a quadratic factor, and quadratic factors have the form ax squared plus bx plus c. Okay, so we would expect f of x to look like this: x plus 2 times what we call a quadratic factor. Now we need to get that quadratic factor here, and one way that we could do it is to divide both sides by x plus 2. So in other words, we'd have therefore the quadratic factor ax squared plus bx plus c would be identical to dividing f of x by x plus 2. And we can do algebraic long division for something like this. Well, I did say that there was two ways of doing this, and I'll do the algebraic long division way in a moment. But the other way is just by simply guessing the values that go into this quadratic factor. So I'll go for that first of all, because that is generally the quickest way. So we'll just put it down here that f of x, okay, we've seen is going to be identical to x plus 2 multiplied by this quadratic factor. So what's it going to be? Well, certainly for the ax squared part, we need x times ax squared is going to give us ax cubed. It's going to be the only cubic term, and we can see that it's got to be 2x cubed. So clearly it's got to be 2x squared that's got to be here. X times the 2x squared will give us the 2x cubed. Now we go to the end here, the constant, plus 24 in this case, and so we know that at the end here, the only time we're going to get a constant out of this is when we do 2 plus 2 multiplied by the constant on the end. And it's got to come to plus 24, so clearly it's got to be plus 12. 2 12s, 24. But this is the term, the x term that we've got to work out. I'm going to write that in then as bx, okay, plus bx just there. Now, how am I going to work this out? Well, we've got two ways that we can do it. We can either look at the x terms or the x squared term. I'm going to work with the x term, okay? It's totally up to you, it doesn't matter. In fact, I'll work with the x term, you can check it out against the x squared term, alright, in a similar fashion. I'll show you what we do. We compare coefficients. I want minus 10x. So in order to get minus 10x, if we were expanding this, the only terms we would get in x would be when we do x multiplied with the 12. That would give us 12x. So we'll just put this down here, 12x. We'd get another x term when we do 2 multiplied with the bx. So that would give us plus 2bx. Plus 2bx. And what we're hoping to get back is minus 10x. So this has got to be identical to minus 10x. So if that's the case, if I take 12x from both sides, I'm left with 2bx being identical to minus 22x, minus 10x minus 12x minus 22x. And if I divide both sides here by 2x, it will leave me with what b is. B would have to be identical to minus 11. Okay? So that would mean that in here the term should be minus 11x. Okay? So that is how I get that value. So I would be thinking something like this then in order to work out what b is. And you could do it just by comparing, as I say, the x squared coefficients. I'll leave it up to you. Check out, see if you can get the minus 7 x squared there. You'll see that you'll still return back to a minus 11 here as the coefficient of x. Now we're not finished with this yet, because it does say that factorize f of x completely, so it does seem to suggest then that this quadratic factor will factorize again, and it does. It goes to two brackets and it's going to be a 2x and an x, and then minus 3 and minus 4. Okay, so that's it factorized fully. Now I did say that you could get this quadratic factor by algebraic long division. So I'm assuming that you're familiar with algebraic long division. If not, you can always go on my website, ExamSolutions.net, look at the tutorials for algebraic long division. But we'll just run through this here, just in case you did want to do it this way. What we would do is have x plus 2 then into f of x. F of x being up here as 2x cubed then minus 7x squared minus 10x and then plus 24. Okay, so we should be able to get this, squeeze this in here. So in the usual way, what do we multiply x by to give 2x cubed? Well, it's 2x squared. And then we do 2x squared multiplied by x plus 2, putting our answer underneath here. So 2x squared times x gives 2x cubed, and then 2x squared times plus 2 gives plus 4x squared. And then what we do is we subtract to work out what the remainder is. 2x cubed minus 2x cubed, well that's 0. And then we've got minus 7x squared minus plus 4x squared, which is going to be minus 11x squared. And then we bring down the minus 10x. And then we start all over again. What do we multiply x by to give minus 11x squared? Well, it's going to be minus 11x. And now we do minus 11x times x plus 2. Minus 11x times x is minus 11x squared. And then minus 11x times plus 2 is minus 22x. We now subtract these two from one another to work out what the remainder is. Minus 11x squared minus minus 11x squared is 0x squared, nothing. Then we have minus 10x minus minus 22x, in other words minus 10x plus 22x, which is going to be 12x. We now bring down plus 24, and again we repeat the process. What do we multiply x by to give 12x? And that's going to be plus 12. 12 times x plus 2 is going to give us 12x plus 24. And again, if we subtract these to work out what the remainder is, we end up with 0, which is what we would expect. Remember, x plus 2 is a factor, so it should go into that exactly. If we didn't get 0, then obviously there would have been an error somewhere in here. Okay, well that will give us our quadratic factor, 2x squared minus 11x plus 12, and then you can just factorize that again in the usual way. Alright, so I hope that's given you some idea on how we can go about doing this particular question.